This is Calculus 1 in differentiation in class practice, number 24, problem 34. And this is the last one of number 24. And this one says find the equation of the tangent line to the curve y equals 3 arc cosine x divided by 2 at the point 1 pi. Well, so I know I'm going to use eventually my tangent line. My point slope form here is what I love to use, my handy dandy point slope form. So we're going to eventually use that. And so we already have the point. The point 1 is going to go here and pi are going to be here. And we have to find the slope, which is the derivative. And this has an arc cosine or inverse cosine, however you want to look at it. So I'm going to start doing the derivative. And when we're done, we're going to plug in the y and then the 1 into the x part. And then we'll be able to have the slope. So I have y prime. So when I do the derivative of this, let's just rewrite it first. I'm going to rewrite this first before I start doing the derivative. So I have y equals 3 inverse cosine, which is the same thing. I don't like the slant for the division, so I'm just rewriting it. It's a little bit shorter. Arc cosine and inverse cosine are the same thing. And then I'm going to set myself up. This is the same as saying a half of x. I'm going to need that later. And also you can call this u if you want, if you're going to start doing the derivative. So I do y prime equals, and I know the derivative is going to be -1 over a radical, but there's a 3 there. So I'm going to have a -3 over radical 1 minus u squared, and u is x over 2 squared. That's a very wiggly line, times the derivative of the inside, which is going to be 1/2. So that comes out to be -3, right, all over 2 radical 1 minus x over 2 squared. Now, I would play around with that and simplify the bottom even more, but because we're going to plug in a 1, I'm going to put the number in right now, so that will be simpler with a number right in there. But you could actually play around with this and simplify it. So I have -3, and we're going to throw a 1 in everywhere there's a x. So I have 1 minus 1/2 squared, and I forgot the 2 there, so it's -3 over 2 radical 1 minus 1/2 squared, which is going to be -3 over 2 radical. So 1 minus 1/4. So this comes out to be radical 3/4. And I do know, now that I can play around with it, that's 2 times radical 3 over radical 4. And you're multiplying. So, whoops, I'm thinking ahead because radical 4 is 2. So here's radical 4. And because square root of 4 and 2, I can cancel this out. So I end up with -3 over radical 3, which is not wrong, but it needs to be rationalized. So I'm going to multiply this. And I know you can put this in your calculator, but I just find this so much more fun. So let's keep going. So I have y prime of 1 is going to be -3 over radical 3. And we're going to now rationalize that by saying that's times radical 3 over radical 3. So that's -3 radical 3 over 3. Then these divide out to make a 1. So the slope of our tangent line is negative radical 3. See, wasn't that way more fun than if I just threw it in the calculator? Of course you think so. So now, so there's my slope. So I have y minus y1, and the point is 1 pi. So pi is going to come here, okay, equals the slope, which is negative radical 3, x minus 1. And I would be happy if you just move the pi over. Why do I keep hitting that? I'm so sorry. I have all this stuff coming up. So what I'm going to do here is just basically move over the pi to the other side. And when I do that, I have y equals negative radical 3, x minus 1 plus pi. You could actually multiply it through if you want, but this is good right here. And there's your equation of your tangent line. Thanks for watching.